Hello everyone, welcome to today's LeetCode question. It's 1539 kth missing positive number. So they have given us an array ARR of positive integers sorted in an strictly increasing order and an integer k. We have to return the kth positive integer that is missing from this array. So they have given us an array that is strictly increasing and we have to find the kth missing element from that array. To find the kth missing element from that array, we can just traverse over the array and find it in O of n, but it is a simple algorithm to find it in O of n. But we are not using any advantage of the array that is sorted. So for the sorted array, we can just use a technique called as binary search, which works in O of log n. So in the follow-up, they have also asked that could you solve this problem in less than O of n. So we can solve this in O of log n, and we are actually going to solve it in O of log n. So let's get started with the problem. I'll explain the problem by coding it up. So first of all, I'll make n equal to ARR of that ARR of size. So let's store the size of the array, and I'll make my start equal to 0 because it's what we need in a binary search, and end equal to n. So you may ask, in binary search we just do end equal to n minus 1. So why here we are doing end equal to n? The reason behind it is a formula, and the formula is something like this. So how we are going to tackle this problem is very easy. Suppose we have this array and we have to find the k equal to 5. So kth missing element is the fifth missing element, and as you can see, the fifth missing element will be nothing but 9 because it's the fifth element which is not present in the array. So to find the element which is not in the array, what we are going to do is we are pointing to this element as start, and here the imaginary element as end, and then we will get our mid, and we will check if our mid element is on the correct position, or if the mid element, how many elements are missing lesser than the mid element, and then we are moving our start and end pointer, and at some point in a time we will be on a position that we can tell that our current index has greater than or equal to k elements missing. If the current element has greater than or k elements, greater than or equal to k elements missing, then we are interested in an element of that particular index minus 1. So it will be nothing but the, suppose my start is there, so my start is at the index where I have greater than or equal to k elements missing, and therefore I'm interested in the index start minus 1. So what we can do is check how many elements are there which are missing lesser than start minus 1. So we can do this very easily, something like array of start minus 1 minus start minus 1 minus sorry, minus 1, and this will give us missing elements till start minus 1 index. And so from start minus 1 we need k minus this particular expression in numbers. Okay, so from that start index we need k minus these particular numbers. So we need this. So if we can find these numbers, then we can find the kth missing element. So what we can do to find it, we have array of start minus 1. We can just add array of start minus 1 plus this particular thing, plus how many elements we need to find the array and how many elements we need to find. So if I just try run on the above array, this particular array, you can see that, let's see. Okay, I have my start equal to 0, and let's annotate the indexes first. This is 1 0, this is 1, this is 2, this is 3, and this one is 4. I have my end equal to 5 because length is 5, and according to this you can figure out that my mid will be equal to 2. As my mid is equal to 2, so my mid element is 4, and you can check the 4 must be at position 3, but it's at position 2, so the difference is 4 must be at position 3, but it's at position 2. Must be at index 3, but it's at index 2. Therefore the missing elements before it are 1, and as you can see the 1 is missing here, so it's definitely working. So as the one element is missing on that side and we need k elements missing, so we can just increment our start. So therefore on the next part we will increment our start something like this. We will increment our start to the mid plus 1, which will be 3, and then accordingly my mid will be equal to 4, and as my mid is 4, my mid is 4, it's 11. I can clearly see that for 11 it will be like 10 minus its position is 4, so 6 elements are missing. The 6 elements are missing, but 6 elements are greater than k, so I have greater than k elements missing, so I can just reduce my end to the mid, and therefore my end will be reduced to the mid, something like this. And now my mid will be equal to 3, and on the third index I have 7, so 7 must be at index 6, but it's at index 3, so there are 3 elements missing. As 3 elements are missing but we need 5 elements missing, I can increment my start to mid plus 1. So I incremented my start to mid plus 1, which will be equal to 4, and my end, my mid will be equal to 4 again, but this won't execute because my start is equal to end and I'll break on that situation. So now you can see that my start equal to end and I am on this position, it's 11. So at 11 you know that it must be on position 10, but it's on position 4, so there are 6 elements missing, and as there are 6 elements missing, I can say that these elements are greater than or equal to k. The missing elements are greater than or equal to k. So we are interested in the previous index. So we are interested in the previous index. The previous index is 3. So index was 4. The previous index is 3, and we are interested in 7 now. And for this, how many elements are missing before 7 is equal to nothing but 7 minus 1, that is ARR of start minus 1, minus 1 minus ARR of start minus 1, which is ARR of start minus 1 means 4 minus 1, which is 3. So as you can see there are 3 elements missing. As there are 3 elements missing, it definitely means that we have to add k minus missing elements, which is equal to nothing but 5 minus 3 elements, which are 2 elements. We must add 2 elements. So we must add 2 elements to whom? We must add 2 elements to 7. So we must add 7 with the 2 elements, which will be equal to 9. And therefore this formula can be written as this particular formula, and we can just modify this particular formula something like this: k minus ARR of start minus 1 plus start, but the ARR of start minus 1 plus start must be added with ARR of start minus 1 plus k minus ARR of start minus 1 plus start, and this will be omitted. These two parts will be omitted. Therefore we are left with k plus start, and that will be our answer. So let's code it up. My start is less than n, my mid will be equal to start minus n minus start plus n minus start divided by 2. If my ARR of mid minus 1 minus mid is less than k, then my start will be equal to mid plus 1, else my end will be equal to mid, and I'll just return start plus k, and this should work. Let's see if it's working or not. It's working. Let's submit it. And this is O of login algorithm. It's working pretty fine. So I hope you understood the solution. I'll see you in the next one. Thank you. Don't forget to share this video with all your friends who are stuck up in this problem. I'll see you in the next one. Thank you.